Okay, we're talking about atomic radius and electronegativity, and we're talking basically about periodic trends. What happens when we go from the top to the bottom down a group and from left to right across a period. So let's do a quick little review of those type of things first. So first off, remember on the periodic table, a group is going to be our vertical column. And so all of the trends that we talk about, and there's going to be 4 of them split over 2 videos on this, all of the trends are going to be from the top of the periodic table to the bottom of the periodic table. And we're going to be talking about period trends as well. And remember, a period is a horizontal row. These are going to be going from left to right, from the alkali metals all the way across to the noble gases. And so let's get right into it. The first of the 2 trends on the periodic table. Okay, so the first trend we're going to talk about is atomic radius. And atomic radius is considered 1/2 the distance between the nuclei of 2 like atoms. And so we'll give you an example of what we mean by atomic radius. So let's say if we're looking at the neutral hydrogen atom with a that has 1 proton and 1 electron. If we were to draw a model of it, we'd have our proton in the nucleus, and then here would be our electron cloud, our s orbital, and somewhere in there would be our electron just zipping around in that electron cloud. And if we had another, let's say here's our 1 proton in our second, like that, 1 proton. And what hydrogen will often do is will bond together with another hydrogen to form what we call diatomic hydrogen, which is two hydrogen atoms bonded together. We would say, and that this looks like my nucleus is a little bit off on this one, not necessarily perfectly to scale. Let's make the nucleus about right there. So we have our 2 electrons zipping around. So our atomic radius would be 1/2 the distance. So it would be 1/2 the distance between the nuclei up here. So there's our atomic radius. Atomic radius. Okay, and so let's talk about what the trends are on the periodic table. So here's a periodic table, and so our first trend is going to be as we go down a group on the periodic table. So let's say where our alkali metal group is in group 1A, what is going to happen is our atomic radius will increase, meaning our atoms will get larger and larger and larger and larger. And the reason behind this is we have more electrons in higher energy levels. And each time we go up an energy level, the energy level gets larger. We have larger and larger and larger orbitals. For example, if we can give you the example of once again, our hydrogen, just that 1 electron in its 1s orbital, 1s1. And if we go down 1 to lithium, we have a lithium atom which has 3 electrons and 3 protons. And so the first set of electrons are going to be in that 1s orbital. There's 2 electrons, and then we'll have another orbital which is larger. Let's pretend that's my orbital. That's a horrible orbital with another electron. So those are 3 electrons, and so we have now our 1s2 and our 2s1 orbitals for the lithium. And as we keep adding electrons at greater energy levels, next comes the p orbitals, and then you're going to come into 3s, and everything's going to get larger and larger and larger. So again, the atomic radius is going to increase down group. Now, going across a period, the trends always reverse themselves. So whatever the trend is going down a group, going across a period, it's opposite. So if the trend is going down, increase, the trend going across is to decrease. And the reason for this is we have more protons, and those protons are positive, and we call it effective nuclear charge, and that nuclear charge increases with positive charged protons, and it pulls the electrons in tighter, because essentially the electrons are not being placed in higher energy levels, they're being placed in the same exact energy levels. So again, increase down, decrease to the right. And so now we can ask questions like this. Our sample problem. So he says, which of the following has the greatest atomic radius? So again, remember, atomic radius increases down. So we're looking at here lithium, sodium, potassium, and rubidium. If atomic radius is increasing down, the furthest down the periodic table would be the greatest atomic radius. So that's going to be rubidium. Okay. Next question. Which has the smallest atomic radius? Well, we have carbon, nitrogen, oxygen, and fluorine on this question. And so here's carbon, nitrogen, oxygen, and fluorine, just like that. And so now as we travel to the right, we decrease the atomic radius, and so the answer is going to be the furthest to the right, which is fluorine in this set. So fluorine would have the smallest atomic radius. The next one is, which of the following has the greatest atomic radius? Phosphorus, sulfur, arsenic, and selenium. And so let's look at these guys on the periodic table. Kind of hard to see. So we have phosphorus, sulfur, arsenic, and selenium right there. I'm going to rewrite these down here just so we can see them a little bit bigger. The way they appear on the periodic table is we have phosphorus, sulfur, arsenic, and selenium. And so remember, as we go down, we have an increase, and as we go to the right, we have a decrease in atomic radius. So we're looking for the largest. So as we go down, so arsenic and selenium are both going to be bigger than phosphorus and sulfur. So we can kind of get rid of these guys. And then so that means it's now between arsenic and selenium. But remember, as you go to the right, our size decreases, so arsenic is going to be our largest. Okay, the next trend that we're going to look at is going to be the trend of what is called electronegativity. And electronegativity is defined as the attraction or the pull an atom has on electrons. So some atoms want to really pull electrons in close to them. And this happens while being bonded to other atoms. For example, great example of this is water. Water has a formula of H2O. We have a single hydrogen atom bonded to an oxygen atom, bonded to another hydrogen atom. There's our H2O. Now, when these atoms bond, and we're going to get more into detail of this bonding, they share their electrons so that they can have noble gas electron configuration. We call it an octet rule. And we'll get more into this later. But they don't share equally. And so we have to look at the trend for electronegativity, this attraction, this pull of electrons. And that's what we're dealing with here. So let's take a look at our trend. So our trend for electronegativity is as we go down the periodic table, the electronegativity is going to decrease. It decreases down. And that means as we go to the right across a period, the electronegativity is going to increase. And it will increase all the way over to fluorine, which is the king of electronegativity. Now we say it increases to fluorine is because the noble gases here do not bond typically with other atoms. So we say that fluorine is the king of electronegativity, even though it's one group to the left of the noble gases. Noble gases don't bond. Okay, and so now we can look at sample problems. And so let's look at our first sample problem. It says, which of the following has the greatest electronegativity? And we have 4 to choose from. We have potassium, we have calcium, scandium, and titanium. Oh, all in the same period. So remember, going to the right across the periodic table, electronegativity increases. So the greatest one is going to be whoever's furthest to the right. In this case, the answer is going to be titanium. Let's look at the next one, which is the smallest electronegativity. And we have oxygen, fluorine, sulfur, and chlorine. Okay, so remember, our trend is as we go down, it decreases, and as we go to the right, it increases. So we're looking for smallest. So oxygen would be greater than sulfur, and fluorine would be greater than chlorine, so let's get rid of those because we're going down. And then if we increase to the right, chlorine is going to be larger than sulfur, so there's our answer, sulfur. Okay, and so those are the first of 2 trends. There will be another video following this, part 2, where we're going to deal with 2 of the other trends that we can make predictions about what happens as you go down a group from top to bottom and left to right across a period on the periodic table.